So let's dive into the next lesson here of loops, which is going to build upon our previous video looking at lists. So if you click on this tutorial, what you're going to end up with is this Kaggle notebook. I went ahead and got it fired up in my own account. This notebook in this lesson is basically all about what's called loops, or for loops and while loops. Both of these types of loops are extremely useful tools for applying some sort of method or set of code to a bunch of different items. We'll get started by looking at an example here. So we have our trusty planets list of Mercury through Neptune, and we have an example of a for loop here. It's going to go through each of the items in that list of planets, and it calls each of the items as it applies whatever code to it, it calls it a planet. For planet in planets, colon, the next line starts a chunk of code which is nested, meaning that it's 4 spaces over. And this nested code in this case is just going to print out the name of the planet. If we run this chunk of code, we're going to see that it prints out the different items in that list. We can make this a little more interesting by adding a \n so that it puts each of the items that it prints on a new line. So if we rerun this, whoops, sorry, it's the different one, \/ instead of slash, there you go. So with \n, you're going to see that it printed out each of the items on the list one line after another. A for loop specifies the variable name to use, in this case planet, and the set of values to loop over, which is a list such as planets, and you use the word in to link them together. The object to the right of in is any object that supports iteration, so lists and tuples and things like that. And anything that comes before it is what you call that item as you go through each of the items in the list. Here you have a little more complex example where you have a tuple full of integers, and you're going to create a for loop that goes through each of the integers in this tuple and essentially just keeps multiplying it by the product of the one before it. So you've created another variable here called product, which is set equal to 1. And as it goes through each of the items in this tuple, it's going to take the product times each of the items, or MULT or mult, and reassign product to that result, and then go through all the rest of them and continue to multiply each product by the one before it. So here we can go run the whole thing, and it ran through all these, ended up with a value of 360. It's gone through and done that multiplication the 6 times through that tuple. You can also create for loops which use strings. Here is a situation where we're creating a string with the title S. It's got this long string. There's a certain message. And you can do a for loop to go through each of the characters in string. So string is essentially a list of characters. And you can, if the character is an uppercase character in that string, it will print that character. Here, when we run this, you can see it's gone through this entire string. It's pulled out only uppercase. So H, and here's E, and down here you have L and LO. And what you end up with is hello. So it's gone through this entire string and pulled out just the uppercase letters. So now we'll look at a function called range, and range allows us to create a list on the fly that has a certain range, let's say. So here's an example of using range 5, which is going to create a list from 0 to 5. And for each of the items in that list, it's going to print doing important work I equals, and then I. So here when we execute this, you'll notice that it'll say doing important work, I equals 0, doing important work, I equals 1, etc. So you're going to see that it's gone from 0 to 5. It's created a range of 5 items. The next Python function, which is super useful, is called while. So instead of the for loop just going through each of the items in a list, you're going to use while to just keep running a loop until a certain condition has been met. It's a little more complex. So here you can see you're creating a new variable called I. You're setting I equal to 0. While I is less than 10, you're going to do something. In this case, you're going to print I, and you're going to increase I is essentially what's called a counter, and you're going to increase that counter by 1. The notation of plus equal to is taking the value of I and adding 1 to it each time it goes through this loop. Here you can see when we execute this, it's going to show 0 through 9. It's going through the loop and printing it out. Once it reaches 10, as long as this condition is true, and once it becomes false, the while loop will actually end. So you have to be really careful sometimes with while loops. If the condition's never met, you have what's called an infinite while loop that'll just keep going forever. You have to kill the kernel in a sense. You can go up here to run, and you can go to stop session or restart the kernel if you ever create an infinite while loop. The next part of this lesson, I'm not going to go into detail. It's called list comprehensions. List comprehensions are just a much more advanced way of creating a for loop, for example. Instead of writing out multiple lines of code, you're actually condensing it into one line. So here you can see is a chunk of code where you are creating basically a for loop in a single line of code, which is basically, you can read this as for n in range 10, print n squared. If we execute this line of code, you're going to see that it's created this for loop. It's gone through a range of from 0 to 9 in terms of the indices, 0, 1, 4, 9, 16, 24. So it's basically each of the indices it's taking to the power of 2. So n star 2 is n to the power of 2. So if you come down here, the same exact thing is being expressed here in the way we just learned it, where you have a for loop, for n in range 10, you're doing squares dot append n to the second power and printing this loop. So you can see here, this is the same thing. It's a different syntax. It's a different way of writing lists and for loops and while loops. Here you can see you can add if conditions. I don't often use this type of I don't use this type of syntax very often. It's for people who really like to be very efficient with how much code that they use, and they really want to fit everything into one line of code. I'm not going to go through this in detail because, like I said, it's a little more advanced. I don't use it very often, to be honest. They bring up an analogy with like SQL queries, which is also a very advanced topic. So I'm going to skip over all this stuff and down here they even say at the end which of these solutions is best. So there are different ways of doing the same thing. It's really up to the person. But they do give the suggestion that according to the Zen of Python, which if you click on this link, it goes into a website which kind of talks about the Zen of Python, where readability counts. And it's essentially, to me, a very explicit for loop, as you see up here, is more readable than what you see here, the notation you see here using list comprehensions. So it's a personal preference. Maybe at some point you'll be wanting to make your code all fit into one line and you don't want to create for loops the way it was shown at the beginning of this, but that's up to you. So to solidify your understanding of lists and loops, for and while loops, please check out the coding exercises if you'd like to practice.